And welcome, chemistry students. It's Mr. Ball. I hope you're having a fantastic break. It's time to get you some instruction, though. So today we're going to introduce you and go over a little bit what we should have been going over already. But first, I want to show off my desk setup. Got some microscopes over here, so we get to have a little bit of good time. Some slides for later. Nice little globe. We have a dehumidifier so that it doesn't get moldy up in my basement. We have a bunch of my wife's stuff. I have, in case I need to sneeze, some Kleenexes, some Windex, keep stuff clean. Indian's hat, because it's awesome. My wife's mug, because I stole my wife's mug, don't tell her. Her lamp, because I stole her lamp too. And a little flower girl basket. So, that's pretty cool. Anyway, back to the chemistry. So, when we left off, we were going to be starting to talk about ion formation. We talked about it all a little bit, but we haven't got too in depth. So your assignment was to do Chapter 7, Section 1, ion formation. And then, when we turn all the way over to page 209, we have 6 questions to do. So when it comes to these 6 questions, I want you to really just dig in and do the best you can. We're going to go over a couple things that'll help you out with some answers today, specifically for number 1, as well as number 4. We'll also talk about being able to do electron dot structures. So electron dot structures really simplify the electron configurations that we've been doing in their outer shells. But to show you a little bit more on that, let's start with the octet rule. So the octet rule, it says that 8 electrons in the outer shell containing electrons. If you fulfill the octet rule, that means the outer shell can have 8 electrons where it contains any electrons. So I gave you an example at the bottom and asked you a question. Which has a complete octet and is more stable? So having a complete octet makes an atom more stable. Here we have regular sodium right there, this bad boy. And then over here, you'll notice sodium is missing an electron. So it's an ion. It's actually a cation because it's positive. Hopefully you learned that in this chapter. But because in its outer shell that contains electrons, you see how it has 8 there? Because it lost this little guy up here, this ditty. It actually is more stable than this guy. So the ion is more stable than the element in this case because it has a complete octet. 1, 2, 3, 4, 5, 6, 7, 8. Isn't that nice? That's always easy. So this one, more stable because it completes the octet. That might help you with number 1 in your homework. Wink, wink, nudge, nudge, hint, hint. The next thing we're going to cover, quick how to do a Lewis dot structure, because you already know how to do it. So when you go down here, you look at the Lewis dot structures. Oh, and real quick, the only exemption from that octet rule is hydrogen and helium because they only have room for 2 electrons on that energy level. So instead of 8, it wants 2. But anyway, I digress there. Lewis dot structures. We look over here, we see all these energy levels that are full on these guys. So we want an easier way to be able to draw them. So our easier way to draw them, actually, let's sneak on over to Mr. Lewis, who came up with this. Actually, he was probably a doctor, so let's not shortchange him. He's probably Dr. Lewis. He figured out that the only electron level we're worried about is the outside one, because that's what interacts with other atoms. It's a really cool thing, and it helps you not to have to worry about so much. So with B, which stands for boron, and hopefully this video isn't too boron for you. Yeah, I know you missed my dad jokes. If you look over here, you can see that boron only has 3 electrons in its outside orbital. So the inside orbital, since the inside one always has 2, it's actually full. But the outside, 1, 2, 3, only has 3. So to make the Lewis dot structure, we go over to it. We, of course, have the symbol boron, for B for boron. 1 electron, 2 electron, 3 electron. That simple. Very, very easy. We don't have to worry about the other full electron levels because those don't really react. We just want to see this guy. We want to see it in action. And only the outside electron levels actually interact with others. So something a little more complicated now. Go to chlorine, Cl. So with chlorine, you'll see it has 2 completely full electron levels. First one being 2. The second one has that complete octet. It has 8. 1, 2, 3, 4, 5, 6, 7, 8. Once again, what's an octet? An octet, 8 electrons in the outer shell containing electrons. That should not be a question mark there. It's like I'm Ron Burgundy. No, it's 8 electrons in the outer shell that contains electrons. That's what an octet is. So we go down here, chlorine. We don't have to worry about this first inside shell. We don't have to worry about the second shell or energy level. The only one that isn't complete is this third one. We have 7 here. So we're assigning the electrons like the Pauli exclusion principle, right? That was the bonus on your last test. But that means that 1 goes to each site first. So 1, 2, 3, 4. 1, 2, 3. It matches, see? It's pretty cool how that works. So now we're going to do one live, as you kids say. Let's do it live. So I'm going to erase this little question mark. We have oxygen. Oxygen has a completely filled inner level here with its 2, but then it has 1, 2, 3, 4, 5, 6 in the outside. So let's go Pauli exclusion principle. Put 1 on each site first. Up to 6. 1, 2, 3, 4, 5, 6. See how easy that was? That's just making this a lot simpler and easier. So instead of having to draw all these circles, all these inside energy shells, you get to draw just the valence electrons. That's a good word. I'm going to spell that out for you here. Valence. We've had that as a vocabulary word, actually. But to remind you what it is, the outside electrons are the valence electrons. Now for the last thing to cover today. We're talking about the anion and the cation. An electron loss and electron gain. So, when we're talking about anion and cation, and yes, this cat is happy. I want to point out the smile right there. That's a happy cat. So the anion and cation talk about a positive and a negative ion. Easy way to remember this. Anion sounds very similar to anti, which is negative. You're going to have a negative charge with an anion. A cation is going to be positive. Or if you really like cats, you can be like, that's a positive thing having a cat. I'm allergic to them. That's why I don't have one. So I don't think of it that way. But a cation, positive. All right. So now we have to think of which is electron loss and which one is electron gain. We know electrons, they make electricity, so you get this cool little lightning bolt here. But they have a negative charge. Electrons have a negative charge. So if we add an electron to an atom, it's going to have an overall negative charge as opposed to neutral. If an electron leaves that atom, you'll actually have a positive charge because you'll have more protons than electrons then. So we can look over here. Anion will actually need an extra electron, so it matches up with electron gain. And cation matches up with electron loss. That's the end of the video. Go Browns, and thank you for your time.